So today we're learning about the application of the vectors to the motion. In particular to displacement, velocity, and I will add also acceleration, which is not in your textbook, not in this year's course, but we anyway will do. So if we have position vector x, or r, position of some particle we can describe as a vector r, which might be its x coordinate times I plus y coordinates j plus z coordinates k, and they all can be functions over time. So that is position vector. We describe position of the particle or object at any given time. If you know the function describing change into each dimension. What is displacement? Among physics students, what is displacement? You don't have any change in the position. Unit 1, 2 bit, unit 3, 4, changing the position. So if you have the particle initial position was, let's say, described by always at origin, so by vector A, which is equal OA, and equal, let's say, 3i plus 5j minus 2k, and then particle move to the point B, and the final position is described by the vector OB, which will be 5i minus j plus k. How we can find displacement? We do final position vector minus initial. Because displacement is a change in the position. So we do vector b minus a will be equal to I minus 6j and plus 3k. That will be the displacement when particle moved from point A to point B. Make sense? Now, if you know that this happens over 2 seconds, that this change of the position happens in 2 seconds, and it's moving with a constant velocity. So how we can find velocity? We divide the displacement vector by the time, so we get velocity vector equal divide by time, because displacement equal velocity equal displacement divided by time. So we divide this vector displacement by time, divide by 2 seconds, we get velocity equals I minus 3j plus 1.5 k. That will be velocity vector. We divide it because this change in the position, which is displacement, happens over 2 seconds. And velocity is displacement over time. Okay. So we divide our displacement vector over 2, we get velocity vector. Now speed is the magnitude of the velocity. So to find speed, we find the length of the vector, velocity vector, equals square root of 1 squared plus 9 plus 2.25. So will be equal square root of 12.25, which will be equal 3.5 meters per second. So
you just find the velocity?
What have you done there?
I found speed. Speed is the magnitude of the velocity. So I found the magnitude. How we find the magnitude of the vector? X squared plus b
How did you
squared
learn to do
x squared plus y squared plus z squared.
How did you get root of 12.25?
Because if you know how to square numbers which ends in 5, actually I did not know, I took random numbers, I just realized that what it will be. Because how you 35 squared, how you find 35 squared? Easily in your head. You do 3 times number 1 greater, 3 times 4, which is 12, and you add 12, 25. If you want to square, for example, 85 squared, will be 8 times 9, number 1 greater, will be 7225. So when you see 1225, so from 1225, 12 is 3 times 4, so it has to be 335, but because of decimal point, it will be 3.5.
Damn.
So it's pretty easy.
Wow.
If you know your arithmetic. Makes sense what we found speed. Speed is length of the velocity vector.
And to find velocity, you half the displacement.
Not half. Half because I say the time equals 2. We divide it by time. If time will be 5 seconds, I will have to divide displacement by 5.
So to find displacement, you do the vector minus the vector. To find the velocity,
we do for the vector of the final position minus vector initial position.
Then divide by time to find velocity.
Yes.
Then find the modulus of time
of the velocity. We find the length of the vector, and it's called speed. Make sense?
Yeah.
Now, if we have motion not with a constant velocity, what I'm telling you now, it's not in this year's course, it will not be tested this year. It's called vector calculus.
Oh yeah, for next year.
That's a little bit for next year. So to find the velocity is a derivative of the displacement of the position, but changing the position, so we need to find, and we do it representing, putting dot at the top. So v of t function, velocity as a function of time, will be derivative of the position vector, which will be equal dx over dt times I plus dy over dt times j plus dz over dt k. That's how we can find velocity if we have the position vector is a function of the time. Make sense?
So if I displacement then divide by time, you can just derive.
No, if velocity will be changing. In this case, I said velocity not changing; it's constant. So we just divide by time. If velocity changing, if all those x, y, z coordinate, they change their functions, how they change over the time. To find velocity, we find derivative of all of them. And that's how we find velocity. Now, acceleration is a derivative of the velocity, or second derivative of the position vector. So it will be r double dot of t.
So it's hard about vector calculus. What's so hard about it? Like, if you just derive.
No, and by the way, if you have acceleration, to get to the position vector, what you will need to do? You will need to do anti-differentiation twice. Yes. So that will be equal second derivative of the x over t, I plus second derivative of y over time, j plus second derivative of z over time, that's always over time, k. So that's how we find acceleration, as a second derivative of the position vector. Again, that's all not part of this year's curriculum. This year is only with the, like this here is a part of this year's curriculum. That you will learn next year, but I think it's good to get some idea, especially as most of you have an idea about the motion from the physics. Now, let's consider example. The questions in the textbook and in your booklet are, I will say, sort of baby questions. Solutions for the booklet I put on the campus. It's already there, but we will look at an example, more complex questions, not like that in the book. So, first example, let's consider the next motion. Let's consider if the position vector of the particle changes over time according the next r of t equal cos ti plus sin tj plus, no, it's not, I'm saying, it's not in the textbook, it's not in the booklet, because everything that in the textbook and the booklet, I'm saying, it's basic stuff.
Okay.
We're looking at some real stuff that we will be doing next year. Plus 2k. First question is, what will be the path of the particle? Let's find Cartesian description of the particle. How it moves, what will be the path. Let's consider first motion only. As you can notice, the z coordinate not changing, it's always the same. So let's consider what will be the motion of the particle in the xy plane, in the horizontal plane. If we have x equal cos t, y equal sin t. Let's recall when we were learning about the graphs, the parametric equations, how we find the equation of this, how we connect x and y.
Oh, t.
We will have, because cos squared t plus sin squared t equals 1. So we have x squared plus y squared equals 1.
Alright.
So what is the shape of the path? Circle with the radius. What the radius of the
radius 1.
circle with the radius 1, and where this circle will be if you draw x, y coordinates, let's say x, y and z. All the time z coordinate of this circle of the particle is 2. So this circle with the radius 1 will be at the height 2. It will be with the radius 1, but it will be not in the xy plane, it will be 2 meters above the xy plane. Does that make sense what I did?
2 above, yeah.
Because z coordinate does not change.
Yeah.
So it will be rotating in the circle 2 meters above the xy plane in the circle with the radius 1. Now, what will be the direction of the rotation? Will it rotate, if you look from the top, will it rotate clockwise or anti-clockwise?
I want to say clockwise, I don't know why.
So, how we can decide? What, when time increases, what happens with the, so first, where it starts? When time starting position t equals 0. When t equals 0, we get r of 0 will be equal, cos 0 is 1, so it's I, this is 0, plus 2k. So it starts here. It starts here at the, I'll probably draw it just xy, right, because it's hard, at least for me, to show it in the 3D. I'm not a great artist. So we have it's in this circle, and its starting position will be at x coordinate is 1, y is 0. Now, when time will be increasing, t increasing, what happened with the cos?
0.
What happened? It's increasing cos. When time increases, when t increasing, what happens with the cos?
Decreases.
Decreases. What happens with the sine?
Increases.
Why? Oh no.
It's a unit. It's
If
like
you
a-
increase sine from 0,
Yeah.
what will
Oh,
happen
like
with it?
this.
So that will means it moves
Yeah.
anti-clockwise. They're just using some simple reasoning, we can decide, find the rotation, the direction of the rotation. Make sense?
Yeah.
If it asks, like in the test, to like show what direction, do you just like choose a point, just set it?
No, first you always, first you need to find initial position, always substituting t equals 0. And then you look how the x changes,
Okay.
how the y changes. From there you can decide is it what direction it moves. This year you will not be tested on this.
Alright.
Yes?
If cos decreases and sine increases, how do you determine that it goes out?
We know where it starts. If you will move this way, we will have the both negative. But when we increase t from 0, it has to be both has to be positive, right?
Yeah.
So if you substitute here, let's say pi and 4,
It's like a unit circle.
pi and 4, we will get root 2. We have starting position was 1, 0. When time equals pi and 4, we will get the position will be root 2. Yeah, good. So make sense this example. Let's consider another example, 2 more examples, and then you will practice on the much easier questions. Let's consider another example. We have position of the particle given by the vector function of t equal 400 ti plus 500 minus 5t squared j, just two-dimensional motion. And first, so this is x and y, it's x horizontal, y is vertical axis. So we consider two-dimensional, and this is a like projectile motion, just not with acceleration g equal 9.8 down with different acceleration. So we throw something at the angle to the horizontal, we throw projectile. First question is, what will be the time, how long it will take to get to ground again? How long it will take to hit the ground? We start, so when t equals 0, what is its position? Let's start from there. T equals 0, we get that position is 500 j. So it starts here. It starts here at the height 500. Does it make sense how we found its starting position? We just take time equals 0. Now, to find when it's hit, to find time when it hit the ground. When it hit the ground, when the y position is 0. So we need to solve 500 minus 5t squared equals 0. So you get t squared equals 100, t equals 10 seconds. Why I take only positive 10? Because time always positive. So it will take 10 seconds to hit the ground. Make sense?
So in these kind of questions, you can ignore the I, because like.
I in this about the height, yes, because I is the horizontal. In this case, it's two-dimensional, where it says the x horizontal, y vertical.
Yeah.
That was part A. B. Find the speed at which projectile hits the ground. To find speed, let's find velocity. To find velocity, we need to find derivative. Velocity equals derivative of the position vector. So it will be equal 400i, derivative of 400t, obviously 400, minus 10t j.
Do you want us to derive or to?
It's derivative. I found derivative dx over dt, derivative 400t over x is 400, derivative 500 minus 5t squared, derivative over t is negative 10t.
400 squared.
Make sense?
400 squared.
Derivative, we derive x, this is x of t, this is y of t. Derivative of this is 400, derivative of this is negative 10t. So, when it hit the ground at the time equal 10 seconds. So what will be when time equal to 10? We'll get velocity at 10 equal 400i, horizontal component does not change, minus 100j. I substitute because it's asked to find with which speed it's hit the ground, so we find velocity at time 10 seconds. Joseph, question?
Can you not just make it okay?
Sense of direction.
Yeah, true.
No, how we can find the speed?
Just 400 squared plus
It's a
100.
magnitude of the velocity. The magnitude of the velocity equals square root of 400 squared plus 100 squared, which will be equal 160,000. So to save time will be 100 root 41 meters per second. So we just found the magnitude of the vector v at the time t. Make sense? Next question. Maximum height of the projectile. Come on, physics students, how we find the maximum height? What we need to find? What determines the maximum height?
Physics.
When the velocity is 0.
Which velocity? Does horizontal velocity?
That's
Huh?
But we already know it's 0.
When the vertical
Yeah.
component of velocity is 0.
I agree.
Horizontal might be not 0, because vertical is 0. At the highest point, vertical component velocity is 0. So we have this as a vertical component of the velocity, 10t equals 0, obviously t equals 0. That means that the highest point is a starting point.
Let me test it on this.
Third time,
No.
say this year.
Okay, sure.
This all we will do next year.
Wait, Mr. V,
Yes.
how come you don't graph displacement but you graph y with respect to like x, you know?
What do you mean? I cannot draw any graphs at all.
Yeah, but like if the y-axis is that, what are you graphing? Are you graphing r? Or are you graphing just y? Because the maximum.
Y against x.
Yeah, so but the maximum point of displacement is not that. Like
You don't need to find the x.
Vertical. The question asks about the maximum vertical point in vertical direction. Does this motion horizontally affect its vertical coordinates? So we're looking when the vertical coordinate is at maximum. Make sense?
Yeah.
So we found that it will start at its maximum, so maximum height is 500. And okay, and the last one, what the initial velocity? What is the initial velocity?
What's the velocity at 0? Sub on 0. You get
Sub in 0,
0.
we get, no. Yeah.
Oh, no, you get,
no.
you get 400.
V of 0 will be equal 400 I. So it started horizontally, its initial velocity, horizontal, 400 I. Velocity initial is when time equals 0. And last question, what is the acceleration?
Derive that again.
We find derivative of
400
the
minus
velocity,
J.
and that will be acceleration, which equals second derivative of displacement, will be equal negative 10g, which is pretty much becomes the, if you take g equals 10, that we will get, let's find its path. Let's find the Cartesian equation of its path. How will we find Cartesian equation of the path? We have the x changing according to x equals 400t and y equal 500 minus 5t squared. How we find the relation between y and x?
You do the same thing, so you have t equals x on 400, so you sub in.
We eliminate t, we do t equals x over 400, and we substitute it here, we get y equal 500 minus 5 times x squared over 400 squared, and that will be parabola. That will be equation of the parabola. So it will move in the parabolic path. Now we can of course simplify it. Make sense? Like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, Hezbollah, etc. Support Ukraine and Israel.